Additional science chemistry, topic 5, chemical reactions, rates of reactions, catalysts and heat energy end reactions. For a chemical reaction to occur, particles must collide, but not only that, they must collide with enough energy for a reaction to occur. We might refer to these as successful collisions. The rate of a reaction tells us how fast the reaction occurs. It can be found by dividing the amount of reactant used or the amount of product formed by the time taken to do so. One practical way of doing this might be to collect and measure the volume of gas produced. The rate of reaction can be increased in 3 key ways. Increasing the temperature gives the particles more energy, so the collisions are more likely to be successful. Increasing the surface area of a solid, for example by grinding it into smaller pieces, means that there's more surface area for the collisions to actually occur at. And finally, increasing the concentration means there are more reactants, more reactant particles, so again more collisions will occur. Catalysts are a way of speeding up a reaction, and the great thing is they don't get used up during the reaction, so only a small amount of them is needed. Car exhausts contain a part called a catalytic converter. In a catalytic converter, the carbon monoxide and unburnt fuel from the engine are reacted together with oxygen from the air. It's an oxidation reaction, and that releases carbon dioxide and water. To speed up the reaction, a catalyst is used, and the catalyst is coated onto a honeycomb structure. This increases the surface area, thus increasing the rate of reaction. The catalyst also works best at higher temperatures, such as when the car has warmed up. During a reaction, bonds between the atoms of the reactants must be broken, and that process needs energy. Meanwhile, when the products are formed, bonds are also formed, and this process releases energy. Exothermic reactions are when more energy is released from the making of product bonds than is needed for the breaking of the reaction bonds, so overall energy is given out. And there is a temperature increase. This is what happens during combustion or explosion reactions. Endothermic reactions are ones where the energy needed to break the reactant bonds is more than the energy released when the products are made. So overall, energy needs to be taken in from the surroundings. This causes a decrease in temperature during the reaction. An example would be a cold pack that you might put on a sports injury. When you hit the cold pack, it causes an endothermic reaction between ammonium nitrate and water, which takes in energy from the surroundings, causing the pack to feel cold. Energy change diagrams show the amount of energy stored in the reactant and the products. In an exothermic reaction, there is more energy in the reactants than the products, so overall energy is given out, and in an endothermic reaction, more energy is stored in the products than the reactants, so energy must be taken in.